me say a few words to begin with. Welcome everyone. I'm Peter Cavola, and today we'll be covering the first session. So the landing zone we're looking at is called one operating entity. It's our most common deployed landing zone, and can scale, what do we say, to medium to large workload footprint. So we specifically selected this landing zone to be presented today here because of this large versatility. But I also want to highlight we have other different types of landing zones, either for a smaller size or then for some specific customer use cases, even multi-tenancy landing zones that can help for some of the more complex enterprise requirements. All our landing zones, or also what we're going to be looking at today, is essentially a blueprint. And what does a blueprint mean? Blueprint is basically a set of our best practices that come from customer conversations, but also from OCI recommendations on how to run OCI tenancies. And when I say blueprint, so blueprint covers both the design part but also configs. So no coding required, but configs. But since these are still JSON-based configs, everything we're going to see here is completely customizable. Because many times customers come, I don't have with the requirements saying I don't have this particular environment, or I want to have additional requirements for UAT environment. And just to say this, everything is completely customizable, allowing even to create custom versions or custom landing zones as needed. So, and also all the blueprints that we have are based on the same set of Terraform modules. So the core remains the same of our all landing zones. And what changes is basically the definition and the design of the landing zones, just because, as I said, everything is customizable. And depending on the size of the customers, we essentially already like pre-customized and created a different landing zones and packaged them together. Throughout all our landing zones, our key design principles were, of course, first of all, SYS benchmark. So Oracle is publishing our own SYS benchmark and like implementation and recommendation based out of it. And all our modules and landing zones strive to be compliant with all these SYS benchmark recommendations. And one of the key requirements in the SYS or CIS, or also some people call it, is segregation of duties. And segregation of duties is a very important concept. And as we will see in a second, OCI allows us or supports us with its native configurability using compartments and how the IAM engine is structured to accomplish the segregation of duties that we will implement as part of the landing zones. Another key thing when talking about the landing zones is also centralized identity management because we have large existing enterprise customers usually work very hard to integrate all the identities into a single identity provider. And of course, we would like to keep continuing in that approach and OCI becoming extension of what they're already able to accomplish today. So on this first diagram, what I have here, I first want to start basically talking about some common functional use cases when we talk about the landing zone. So first of all, let's have a look on the legend up here. And we have a few very important concepts explained here. So first thing we have here is what we call a landing zone environment. We will get a bit more into the detail in a second, but at least on a high level, landing zone environment essentially means we are able to deploy multiple landing zones inside one OCI tenancy. And most commonly, this is for different requirements because either customers want to completely isolate the data between production and non-production. Let's say there is a synthetic data in the non-production, or also from the networking perspective and some telecommunication components, they have a strict requirements also isolating basically the network flows on the virtual, like a physical layer as well. So we can accomplish all of that by deploying multiple landing zones inside one OCI tenancy. Then other common thing, since we're talking about the environments, is workload environments. So most of our customers will usually have multiple workload environments. Like the common one is probably production, development, testing. And in some cases, there can be even more like a pre-production, UAT, and many other environments. And as I said, like this is completely customizable, so environments could be edited, removed, depending on the needs of the customers. And then once we get closer to the landing zone, usually we have some shared services that we essentially isolate in a different set of compartments. And the goal of these shared services is to support all the applications living inside OCI tenancy. So in most cases, this means a single network firewall deployed in a hub, so a hub and spoke topology, or also when we talk about logging, monitoring, audit logs, and also encryption keys. Many cases, there is a centralized point in a security compartment where we want to collect all these different types of services. And then lastly, we finally get to the applications or to the airplanes, as Jose was mentioning. So we have two concepts for running applications. One is project. So project is our standard applications that we normally think about. Let's say 2, 3 virtual machines, maybe some database or some Oracle SaaS functions to deploy some simple functionality. But then also on the other side, we have something what we call platform. And platforms are usually a much larger applications. So I think a great example to like differentiate is if you think about the Exadata, if you're familiar with the Oracle databases, then Exadata is essentially a very large hardware. And as on this hardware, you can create multiple VMCs or virtual clusters, which would be considered kind of like a platform. But then inside the platform, we can deploy multiple databases. And if we really just look at the database, then the single database could be considered from the project perspective as basically supporting one of the single applications. Another great example of the platforms is probably OKE and OCBS, or our VMware engine, where usually from the OCI perspective, you run OKE VMware, and then OCI doesn't really see into what's happening inside. And then you use the native kind of like resources of that solution to implement, let's say, different environments in OKE or some other organizational techniques. Okay, so what I have on here on the diagram is at least some of the most common user stories. So first of all, we have some team at the customer or like different personas, which will play different roles in operating our landing zones. So most commonly, there is some operations team that is basically responsible at least for like the top level setup of the landing zone, maintaining and operating it. And that first layer of the setup involves at least some common user stories like creating the landing zone environments. So there is essentially a team who needs to like create at least like the first couple layers of our landing zone, and then slice that up and offer different services or different permissions to different teams. Another common kind of like service that is maintained centrally maybe by the operations team is the networking or like security. Which again could be also like split into multiple teams as needed, but at least across from the application point of view, this is a shared service that is offered by all the applications. And then lastly, also operating team plays a role, first of all, by setting up all the workload environments. So deciding what kind of environment should we actually have on OCI, and then delegating the access permissions to other teams. And then normally for each of the platforms and projects, so our applications, we have then a dedicated team that is only responsible for that particular project. And what I wanted to highlight here is usually there is kind of like a requirement of mapping from the organizational team into OCI groups or like IAM groups. and how to map those. And what I hear many customers saying, they're saying like, there is too many groups, like we don't need a dedicated networking group because we don't have a dedicated networking team. But what they don't realize in many cases, people can wear multiple hats. So it's more about making sure we have a flexibility in the future, and also about keeping compliance with the best practices in the industry. And then if some of the teams are missing or some responsibilities are overlapping, the teams inside the organization can be part of multiple groups depending on the goals that they need to achieve. Let me then continue to the compartment layout. So I will first start by showing you like the first two layers of the landing zones, because there's actually quite a bit of information to discuss. So when you create a OSI account or tenancy, you will select one region. And this is like a region where your new OSI tenancy will live in. And then you also get the option to subscribe to multiple regions. So essentially, the tenancy is a virtual slice of the hardware that is then owned and configured using the virtual configuration through OCI. OCI tenancy, also many cases called a root compartment, is essentially the first compartment that we get after we create a new account, and everything else is up to the first user of the tenancy to configure it and set up the other privileges and user groups as needed. And in our operating entities, so on the first layer, as I was saying, we have the landing zone environments, and we have optional. So actually, many customers only go for a production landing zone, but we have the option to deploy one or multiple landing zones depending on the customer requirements. So landing zone is essentially one compartment wraps all our landing zones for a simple access control and also logical organization. And these compartments then contain all the resources that are specific to that landing zone. On the second level, so inside the landing zone, we have then tenancy shared resources. First one we have is the networking compartment. When we talk about the hub and spoke networking, in that case, most commonly this particular compartment then holds the a hub, so DRG, a hub network, and also the network firewall configuration. And this is the only place for all the applications inside OCI or inside this landing zone, how to enter or leave the OCI network. So if any of the projects or platforms wants to go to internet, we have a central control over these types of access, and there is a one place to configure that. And the goal of this is to minimize the risk of misconfiguration, because as we heard from OWASP Top 10, misconfiguration has been number one for many years now, resulting in probably 40% of the cases where companies have been hacked. So we really want to minimize the attack surface here and keep a centralized control with the dedicated teams who have a responsibility for that. The second shared compartment that we have up here in the diagram is our security compartment. And this security compartment is very important because most commonly, many customers want to integrate their logging monitoring with either external services or even deploy their own logging monitoring solutions inside OCI directly. And a great place for that is our security compartment. And also additionally, let's say we have some encryption keys, let's say stored in a vault, then we need a place where do we actually store these encryption keys. And then the last one of the tenancy shared compartments is our platform. And this is kind of like a special case platform where when we talk with the customers, many times there is like the special requirements. Like we have our own Splunk installation and we want to collect all the logs from different projects or platforms. And these applications are usually special in a way that they don't really have particular environments. So they're collecting logs from all the environments. They're providing services to all the other environments. And because of that, we kind of like keep it out of the workload environment structure and create a dedicated platform compartment that doesn't really have any types of environment and then can be used across all the environments. Another great example is, let's say, VMware or Kubernetes. So these are usually pretty large clusters, and they also support a native way how to manage environments on the, we can say, on the platform level. So from outside perspective, then it might seem like VMware doesn't have environment. There is one VMware cluster, so we can put it into this particular compartment. But then inside the VMware, it actually has its own way how it can be further configured and how we can create multiple environments. And this is really about the customer choice, right? So they can decide, like, do we want to run a single VMware, single Kubernetes cluster, and then do the environments within the platform? Or do we actually want to utilize the workload environments that we prepare natively inside OCI and deploy multiple of OK clusters? So let's say OK cluster for production, OK cluster for pre-production. And just to like finish up with the platform use cases, what I also quite often hear is a requirement for backup as a service solution. So most commonly, we want to have backups of whatever we do, whatever we deploy inside the VMs or databases. And for that, third-party applications can be utilized as well. And that means we need a place where do we put actually this application. So this shared platform compartment is again a great example where we can actually put those applications that don't really fit into any of the particular environments. Then finally, we get to the different workload environments. And as an example, I basically have here the full list of what we could think of, what kind of environments customers might want to have. But as I said, this is customizable. So many times we only have a customer who has a production and development, and that would mean we can remove all these other environments that are not really necessary. And maybe last thing before we move on, I want to just highlight again this other non-production landing zone is also one of the choices for the customers that they can decide either to have it or not have it. And it also comes potential with some downsides if we like decide to completely separate on the compartment structure these different landing zones. Because what this is actually doing is if we do hub and spoke infrastructure, this would also result in deploying the network firewall multiple times. And then also like potentially increase the cost, how much we want to spend on firewalls, because like firewalls are usually the most expensive part of the landing zone that we actually deploy. But it's really required by some of the customers. So it's always good to at least have this option to deploy several landing zones basically out of the box as part of the blueprint framework. Then we move in to the different diagram. So this diagram, we are still talking about the compartments, but now instead of basically just looking at the first two layers, we want to look into the full depth of all the compartments that we propose as part of this blueprint. So first important information is OCI supports up to 6 levels of compartments. So we can basically nest those 6 levels deep. And within that framework, we can then also like scale to the site, basically deploying multiple compartments or child compartments within a compartment. And as you see now, I removed big part of the diagram. I only kept 2 of the workload environments. And the reason for that is because whatever we decide on, we want to ensure that there is a consistency across the whole OCI tenancy. Meaning, if we decide on a diagram for what do we do for the landing zone, if we have 2 landing zones, we want to do the exact same thing also for the non-production landing zone. And then the same goes also for the workload environments. So we will focus mostly on the production environments, but that means whatever we do inside the production, the exact same structure is also followed in all the other environments. Then let's maybe look at the one of the environments, so like a production, and we have here again some of the, so you can see here, we call it the environment shared resources, so the layer 3. And the environment shared resources, you might notice that it's basically the same of what we had directly on the top of the landing zone level. And this is done on purpose, but now these compartments serve a slightly different purpose. So it's essentially the same type of resources with the same responsibilities, but now they're environment specific. So if we talk about the networking, then in the networking perspective, this means the spoke network will be deployed here inside the production. We can also have multiple spoke networks. We will talk about that on the next session. And then the spoke networks are all connected to a DRG that is located in the hub, and with the routing established basically to send all the traffic outside of this spoke to go through the hub and through the firewall. Then again, we have a security compartment, and it has a similar purpose as on top of the landing zone. But now, let's say if we talk about the storage of the secrets, like encryption keys or vaults, these are now environment specific. So usually, at least for a production, we want to make sure that the encryption keys used for the production are used only in the production. And then maybe like the non-production environments could have a bit more mixed keys and encryption keys. But at least for the production, we want to be sure that we have a dedicated encryption keys and secrets for the production. And this is the great place logically and also from the permission perspective to actually put it in, because now we know it's really only the production keys and they're not really used from somewhere else. Then we have again the platform and projects. So as I mentioned in the beginning, we have basically two ways how to run applications. And we have the platform compartment, which is essentially, again, the same responsibilities as it would have on top of the landing zone, but now it's environment specific. So if we use OKE as an example, then this would mean we create one Kubernetes cluster per environment. And there is also a dedicated team, as you also like see here in the optional groups. There is a dedicated team for the Kubernetes cluster as well, meaning a group with its own permissions in this particular compartment. And then on the project side, many times like there's quite a few projects because most of the applications are actually very small. If we do the native application, so like the projects normally consist out of like 3-4 VMs. Could be also optionally separated into different tiers if a customer has dedicated team, let's say for a database. Then this project can be like further sliced up into a smaller compartment that we call layers, and then only the particular team can have access in that particular layer. Okay. Then one more thing I want to mention is back to the networking topic. So Vardan will cover on the next session the networking. So I don't want to go too deep into the networking, but I at least want to cover networking from the permission perspective. So our idea here is that all the networking elements for the production are located in this compartment. So that would mean VCN, subnets, and also potentially security lists and NSGs. And now it's again kind of like up to a customer choice. How do they actually want to manage some of the security lists or NSGs? Because there are essentially two options depending on who should be responsible for managing the security lists and NSGs. They can either be located here in the network compartment, or they could be directly in the project, meaning the people responsible for deploying the applications then actually have permissions to modify the security list and network security groups, at least on this specific VCN level. And also like for the VCNs, I just wanted to highlight the resources are like always located in one single compartment, but then also like applications. So let's say a VM deployed in a project one can utilize a network deployed in a different compartment. So how that looks from the console perspective, when you open the VM or like a compute service in the console, it will ask you which network you want to deploy this VM in. And you also have a drop-down box to select in which compartment is actually this network located. And then similarly for the subnet. So we are essentially utilizing cross-compartment permissions where resources are kept based on the duty that they perform in the landing zone. But then with the permissions, we can allow people responsible for project to grant them permissions. For example, create a PNIC, which is required for deploying the virtual machines. Then one more thing I wanted to highlight here, we also have like a lot of customers coming from Asia, and when we talk with the customers coming from Asia, very often they're using the Azure Cloud Adoption Framework, and this particular landing zone or this diagram quite closely matches also with what Azure is recommending. But there is kind of one change that, as you see, we have the environments first, and then we have the applications. And what customers do usually on the Azure side is they switch it around. They first deploy the application, and then as part of the application, they deploy different environments. But we recommend it doing this way on OCI because how the IAM works, IAM is basically closely tied into the compartment layout. And the way how we design the compartments can either make our life simple or very complicated because if we don't have the proper compartment structure, granting permissions to specific groups in to specific resources could actually become quite difficult if the compartments don't directly support us in this way. And then last thing I wanted to talk here about on this slide is you probably see this little signs. It's actually OCI tags. And what we are actually deploying as part of the landings or recommending to do is to utilize a tag-based access approach, at least for some parts of the OCI landing zone. So that is most commonly the networking and the security compartment, because all these compartments essentially serve the same purpose. The resources are just located in a different compartments. And as you might know, there is some service limits on OCI. There is service limits or everything. But we've seen recently quite a few customers hitting the service limits on number of the policy statements. And this tag-based approach actually allows us to eliminate some of the duplicated policies by simply assigning the permissions based on the tag of the compartment instead of basically utilizing the compartment to grant the permissions. Okay. Then we get to the IAM part. On the IAM, I first want to start explaining what different columns we have here. So on the first column, we have the OCI groups. So this is the groups that we will want to be using inside OCI. Then the same as on the previous diagram, we have the compartment structure, just so we can like easily remember what we had there. And we have OCI identity domains. So in OCI, we can create multiple identity domains. And they, again, need to play some responsibility in the landing zone as well. And lastly, of course, the identity domains can also be used to federate authentication. So we can utilize a remote identity provider, like let's say Entra ID, which is quite commonly seen, and relay at least the authentication process or establish a trust between OCI identity domain and Entra ID. And then the authentication will be performed by the remote identity provider. So let's start from the beginning. Once you get your own new tenancy, the first thing we see is there is one identity domain called the default identity domain. And there is one group called administrators. And there is one user in that group. And that's the original tenancy owner. And this identity domain and a group actually plays a special role in OCI. And that is because, I don't know, you might have heard 2 months ago, we got a new functionality called deny statement. And this administrator group is actually excluded from the deny statements to prevent a customer lockouts. Because if you write the wrong deny policy, everyone from the tenancy could get locked out if the policy actually applies to everyone. So to prevent this, we have this administrator group, and those are always exempted from the deny statements. So this group pretty much needs to remain there. You cannot remove it. You can change the members of the group, but it cannot be removed. And what we do as part of the landing zone design, we kind of like repurpose it, or we dedicate it for the break loss users. And the idea of the break loss users is if you set up the identity federation, there can be cases, let's say Azure is down, there is some networking issues, and a federation to the identity provider might stop working. And if that happens, essentially none of the federated users are able to log in. So it's always recommended to have a few break loss users. So normally I recommend to have at least or like exactly 3 break loss users. Of course, like the number can vary a little, but there should be more than 1 break loss user. And we also don't want to have too many break loss users, because the important thing about the break loss users is to avoid using them from as a day-to-day accounts to access OCI. And because of that, the break loss process is quite commonly at customers also paired with the, I call it the two-man principle. So let's say I would have the password to one of the accounts, and then maybe Herman would have the multi-factor authentication token, meaning if we want to log in into break loss users, we actually need to meet physically or have a call and exchange this multi-factor token to be able to log in as a break loss user. Okay, so that may be one more thing I wanted to mention about the identity domain is we recommend to have at least 2 identity domains. So we keep the default identity domain only for the local users, and the only local users we have is the break loss users. And then for the day-to-day users, we create a different dedicated identity domain. We call it the common identity domain. And that one can be used for everything else inside OCI. And as part of this common identity domain, then we create the rest of the groups that we'll be using as part of the landing zone. So all of these groups are basically already sliced up, and there isn't a single group that covers all the privileges. But we could still say the first IAM admin group is quite high privilege, because it's the only group that can modify the permissions on OCI. And if you can modify the permissions essentially with the 2-step process, you can do anything in OCI. So we have IAM admins. The IAM admins are responsible for, first of all, defining the policy. So establishing some framework who can do what in which compartment, which groups can do. And then also play some roles in cases where the customers don't have identity federation, or maybe as a temporary step. They can also be credential administrators, meaning handle day-to-day tasks like this user forgot the password, so someone needs to reset it. So that is very well the IAM admin group. And also one particular thing regarding the API keys. All right, so API keys can be quite sensitive. And out of the box, we don't allow everyone to create API key for themselves, because API keys essentially skips the authentication process because they're already authenticated. And if you have the API key, then you can perform the operations directly without the multi-factor authentication or any approval process. So we normally limit the API key creation as well, and it's only this particular group that can actually do that. Then our next group we have is the auditor admins. This is our usual group, basically view access to everything. So they can see everything happening inside the full tenancy, but they actually cannot change any of the configurations, download any data. So it's really a view access. Then we have a cost administrators group, and this group is mostly for finance people. So quite often customers, they want to keep close track of their spend and billing on OCI, which projects are consuming how much. And for that, we have this dedicated group where even finance people can have access. As part of this, they will get access to all the diagrams, filters, drill downs, and also the option to set up alerts and usage reports. Then we have a security admin group, and this group is responsible for CloudGuard and security zones. And I will get those on the next slide. But this is two very important services that we use to maintain the security of our own tenancy. And that pretty much covers all the tenancy level groups, as you see, and we are getting into the compartment specific groups. Here I wanted to highlight, as you see, we are using layers in the trial. So if you go to our GitHub and download this design or some of the other landing zones that you can find there, normally they use layers, and there is a very useful information on different layers as well. So sometimes it's a good idea to check what is in there. And as you see here on a different layer, we have something called optional, which also includes some of the optional groups and identity domains. So let's first start with kind of like what comes out of the box, and then I can explain the optional things. So first of all, we of course need two groups for the top level compartments. So we need network admins. Network admins essentially are responsible for setting up all the networking services within the landing zone. So that's very simple and covers the whole networking planet. Then we have the security admins, and security admins normally use resources like vaults, vulnerability scanning, logging, or integrations with the CM. And the important thing here is, as I mentioned on the previous slide, we're using tag-based access control. So even if there is one group, this group actually has permissions in multiple compartments granted by the tags. And then out of the box, you will also see both the diagrams and the configuration contain one example project. And the example project, of course, comes with its own group that also like contains some example policies. And this is also like what we have here on the diagram. But let me show you also like all the optional different groups that could be possibly added to the landing zone as well. So in the first step, we were deciding how many landing zone environments we want to have. So in the case, if we actually have multiple landing zone environments, it could make sense to also have a dedicated group managing that specific landing zone environment. So instead of then IAM admins basically overviewing the whole tenancy, some of the responsibility that the IAM admins have originally can be then pushed down into this landing zone environment admins and separate the responsibility for each of the landing zones. Then another common use case is workload environments. So let's say there is a customer, they're planning to have a lot of applications, and they will be kind of like creating them step by step. And creating a new application consists out of creating a new group, new compartment, and assigning permissions to those groups. So there can be kind of more day-to-day group created specifically for that is then responsible for actually performing these tasks. But the work on environment group can also be like possibly replaced by the IAM admins group as well, who can then simply handle the full offset tenancy instead of a particular environment. Also optionally, so we are recommending using the tag-based access control because of the policy limits, as I mentioned. We don't want to like push too many policies at the customers. But if it's required, you can also use the traditional or like more traditional role-based access control, where the different workload environment, yellow compartments like network and security could come with its own dedicated group as well. And then lastly, so the only thing why this platform is actually marked as optional, because it doesn't come as part of the configuration that we deploy. But the goal is really, if we deploy a platform compartment, it should also always come with a platform group that is then responsible for running the applications and only contains the permissions they actually need to perform the day-to-day tasks. And then the last optional group is the layers. So the layer group, most commonly we have layers or like three layers. If you think about three-tier application, we could have a web tier, backend tier, database tier, and then each of those tiers would come with its own dedicated group. But this really depends on how the customer wants to have this set up and how they also work internally. And just to highlight here again, so everything is customizable that is seen here. And I would also recommend, so we, for all this non-optional group, we already pre-create the policies. But I would always recommend you to review which policies are deployed and figure out what's really needed by the customer to ensure that we don't overgrant permissions for something they don't need, and then also potentially remove the example project that we create in the landing zone. Okay, and then as a last thing, let's get back to the identity domains. So I put here another landing zone environment identity domain, but I also want to talk about the identity domains a bit more in general. So compared to all the other cloud providers, or at least Azure and GCP, OCI allows you to create identity domains, which I think the best comparison is to kind of think about it as a on-premise Active Directory. So we can think about it as a VM, and the identity domain essentially handles the authentication part. So it handles users, it handles groups, and then also like federation and so on. And what this means is it gives us a lot of flexibility in a way how do we actually want to manage our identities. And we can also possibly create a dedicated identity domain specifically for applications. So what we commonly see is, for example, Fusion. And all the Fusion environments, they come with its own identity domain that will also appear then inside OCI, depending on how you configure the Fusion. So as a result, we could see multiple identity domains. But at least on a high level, I usually recommend to separate the purposes for which the identity domains are being used. So we want to have identity domain for the OCI users or like users who have responsibility in OCI. And then we set up permissions for those users. And then also possibly application specific identity domains like for Fusion or possibly other applications like Apex. And the goal of these domains will be primarily handling the authentication for those applications. So meaning we don't actually grant the users of those application domains any permissions on the OCI side. And then it doesn't happen very often, but sometimes we also have customer requirements that they actually have different identity domain for production and non-production environment. So what I put here, we can follow the same approach. If we have production and non-production landing zone, we can also separate the identity domain in the case if the customer actually has also like a separate identity providers for those two environments. And then as a last step, I will get to the security zones and CloudGuard. So as part of the landing zones, or at least what we've discussed so far, we created a very nice compartment structure with the groups and policies. But when we hand over the keys to more people, so many times, let's say we are done with the implementation, now we hand over the tenancy to the customer. What I see many times happening is customer starts using it, and they figure out, oh, like it's actually difficult to send the traffic to the hub, and when I am going from the application, what if I just add internet gateway in the spoke directly, and then I don't have to bother with the centralized firewall. So of course, some people might want to do that, but we set up a landing zone for a purpose. It's to bring security to our offset tenancy and establish a centralized control. And what that means, people shouldn't be able to get around the rules that we set up, even if they have the permissions. And we can reinforce our design principles by utilizing security zones. And security zones, they essentially work in the opposite of IAM. So let's say I'm the administrator, but there is a security zone set up that doesn't allow creation of a public object storage bucket. What that would mean, even if I'm the super admin, I have all the permissions that OCI allows, I will get an error of access denied, and you won't be able to create the object storage bucket because there is a security zone deployed that is preventing me from that operation. So as part of the landing zone, we essentially also, out of the box, create a default security zone deployment, specifically on the compartment structure that we have set up. And as a first step, we have the overall landing zone compartment. And there we have two options. So we have either recipe 1 or recipe 2. And these are directly mapped to the sys benchmarks. And sys benchmark is kind of like separated into two levels of compliance. And essentially the difference between these two is, do you want to enforce usage of customer managed encryption keys or not? So sys level 2 enforces usage of customer managed encryption keys, and the sys level 1 does not. Other thing that this recipe 1 or 2 both do is they deny creation of public object storage buckets. So we cannot expose object storage directly to the internet, and the same for databases. So the database can never be exposed directly to the internet from the landing zone. It usually has to go first through some application that can then expose it optionally to the internet in form of some API. Then we have a recipe 3, which is on our hub network compartment. This one, so we have two versions of the recipe for the network compartment. And on the recipe 4, we want to deny creation, as I mentioned, internet gateway, NAT gateway, public subnets. We want to prevent creation of all of those. So we basically say, you cannot do this because this is a spoke compartment and you shouldn't be allowed to create these. And then on the recipe 3, we have kind of like a minimized version of the recipe 4 that of course needs to allow creation of the public assets because this is our entry and exit from OCI. But it still prevents some operations like deletion of the VCNs, subnets, and the network-related resources, more as basically accident or misconfiguration prevention. So it will prevent you from deleting all the VCNs. And also it prevents movement of the resources, of the networking resources outside of the security zone. So if you have permissions and we have a VCN here and someone wants to like move it to a production or something, the security zone will not allow that because it's a movement outside of the security zone, and you will again get access denied. And then we have a last recipe, recipe number 5. This is our workload recipe, and it should be applied to all the platforms and projects. And the important thing here is individually. So it shouldn't be applied to the whole platform or project compartment, but to the individual platform and project. And that is because the recipe 5 actually focuses on a resource movement prevention. So what that means, OCI is very flexible, and I would say like it allows you to be very creative, very good things. So if you want it without the security zone, You could do, let me put the virtual machine in project one, then I put the boot volume in the project two, and I put another object storage for that project in a project three. And technically, OSET doesn't have a problem with that. But as part of the landing zone, we want to like establish structure that is application centric. So meaning all the application specific resources should be located in the application compartment. And recipe 5 essentially achieves that by disabling some of these operations like moving resources or connecting resources from different security zones. And maybe one thing I would mention here for the security zones. So during the landing zone deployment, it's quite often like you need to experiment, you do some mistakes, you need to like redeploy networking and so on and so on. So usually these security zones are deployed as a last step to avoid kind of like difficulties during the landing zone deployment while we are still figuring out what's the right configuration, what's the right way to deploy the resources, because they would prevent you from doing many of the operations on OCI, and you will get very generic error, basically 403, access forbidden, and that's all you know, and you will be scratching your head trying to figure out why I'm actually not able to do this and this. Okay, and then just to summarize, I have one big diagram that essentially covers everything we discussed so far. And it's a matrix explaining all the details about the different types of resources and their placement in a specific compartments. And I don't think we need to go like through the full diagram. So on the left side, or basically as different rows, we have the compartments that we have set up as part of the landing zone. And then as a columns, we have a different OCI resources. And then we have either marked what is yes or no, meaning is this resource deployed on this level of the compartment or is it not? And this is mostly used for like security people and for the review of what's deployed where, because also like with the compartments, it can very quickly get out of hand if we do too many, and we are not clear about the intention, what's the purpose of each of the compartments. So this is pretty much everything I have prepared for today for the security part.